In this video, we're going to talk about the square root method for solving quadratics. We looked at kind of the precursor to this in the last video when we were solving by factoring. So the square root method is based on the difference of two squares. We had something that looked like x squared is equal to 25. And if we want to solve this by factoring, we could move everything to one side. And we see that this is the difference of two squares, so we can factor that as sum and difference. And like we saw before, if you've got something times something equals 0, you can break this up. So we have x plus 5 equals 0, x minus 5 equals 0, and that's going to give us negative 5 and positive 5. So if we are in a situation where we can get this to the difference of two squares, then our solutions are always going to be the positive root and the negative root. Now, as it turns out, it doesn't necessarily have to be the difference of two squares. It only has to be the difference of two squares to get a whole number. But you could do this with x squared and any number. So I could move this to one side, I could factor it as a square root and so on, or I can use this as a shortcut where we go from something squared is equal to a number, and the solutions are plus and minus the square root of that number. So my solutions for this would be plus or minus the square root of p. Okay, so I've got something squared is equal to a number. My solutions would be plus or minus the square root of p. Now, sometimes it's easy to look at, like going from 25 to 5 and negative 5, but not always. So the method is that if you have something squared is equal to a number, you can take the square root on each side. And you have to remember to put in the plus or minus so that you get both of these solutions from the sum and difference. So this is a shortcut of the difference of two squares. So we take the square root on both sides. On the left-hand side, it cancels. On the right-hand side, we have plus or minus the square root of p. So our original problem was x squared equals p like this. All right, so let's try the shortcut method for another one. Let's say we've got x squared is equal to 16. And the square root method says we can take the square root on each side. I've got something squared is equal to a number, so I take the square root. I don't forget to put in my plus or minus because that's important. We want both solutions. On the left-hand side, the square and the square root cancel. On the right-hand side, I get plus or minus, and we can do the square root of 16. That's equal to 4. So my solutions are 4 and negative 4, or negative 4, positive 4. Either way is fine. Okay, so we see that our solutions are plus or minus the square root of the number that we started with. Now, we can do this even if it's not a perfect square. We could have something like x squared is equal to 7, and I can still take the square root on each side. So I take the square root on the left, square root on the right. Don't forget the plus or minus. On the left-hand side, it cancels. And on the right-hand side, I get plus or minus the square root of 7. I can't do anything with that. I can't simplify it. I can't take the square root. So I just leave that as my answer. If you need to, you can separate it as negative square root of 7, positive square root of 7. Okay, so that's the basic idea. Now, typically when we're doing these, we're looking for solutions over the real numbers. Look at the directions to see what they're asking you for. So if we were to have something like x squared is equal to negative 4, okay, I've got something squared is equal to a number, so I take a square root on both sides with my plus or minus. On the left-hand side, it cancels. And on the right-hand side, I've got the square root of a negative number. Now, we can do this over the complex or imaginary numbers, but typically when we're solving quadratic equations, we want the real solutions. So we would say no real solution here. No real solution, or DNE, depending on what your homework wants for that one. Okay, so typically when we're solving quadratics, we want the real solutions, but just look at the directions for what they want you to do there. And for us, we're pretty much going to stick to real solutions. Okay, so these are all pretty basic. We've got x squared is equal to a number. We can extend this to other problems that are very similar. So let's say that we have something like x plus 1 squared is equal to 4. X plus 1 squared is equal to 4. All right, now we could FOIL this out, move everything to one side and see if it factors. Or we can use the square root method and recognize that this is in the form of something squared is equal to a number. That's the key here, is you've got to have something squared is equal to a number. So even though there's stuff going on the inside, I can mark that out for a second, I still have something squared is equal to a number. We're still in the same format as these other problems. Okay, so I can take the square root. Let's see what happens. Square root on the left, square root on the right. Don't forget the plus or minus. And on the left-hand side, we've seen this before. The square and the square root are happening at the same time. Whatever's going on the inside doesn't matter because we've got something squared and then square rooted immediately. So the square and the square root cancel. We get x plus 1. And then on the right-hand side, we get plus or minus, and the square root of 4 is 2. Okay, so we got out of the square, we got into something that we can solve here, just like we did before. It just looked a little bit different to start. So now remember, I want to solve for x. X is my final answer, so I'm going to subtract 1 from both sides. And since these are all whole numbers, I want to get an answer. So my two sets of solutions, I've got plus 2 minus 1, and I've got minus 2 minus 1. So we can go ahead and break those up and find the two answers. That's going to give me positive 1 and negative 3. So my solutions are 1 and negative 3. And you can go back up to the original question and check that. If I plug in 1, 1 plus 1 squared is 2, 2 squared is 4. Negative 3 would give me negative 2 squared is also 4. So you can always go back to the original equation and check, just like we did before when we were solving by factoring. Okay, let's try another one that looks like that. Let's say that we've got x minus 2 squared equals 3. X minus 2 squared is equal to 3. So the first thing we want to know is, can we do the square root method? I need something squared is equal to a number. So yes, we're in the right format. Something squared is equal to a number. So I can take the square root on both sides. Square root on the left, square root on the right. Don't forget your plus or minus. On the left-hand side, the square and the square root cancel. And on the right-hand side, I have plus or minus the square root of 3, and I can't simplify that, so I'm just going to leave it just the way it is. Now I want to get x by itself. That's when I know that I'm done, so I'm going to add 2 to both sides. All right, now this one is different from the one that we saw before. The one before was all whole numbers and I could combine them. This one is a square root and a whole number, and remember from our square root sections, we cannot combine whole numbers and square roots. So I can write this as 2 plus or minus the square root of 3, or I can write the two solutions separately, 2 plus the square root of 3 and 2 minus the square root of 3. So either version of those answers would be fine. Okay, so you get two solutions, 2 plus or minus the square root of 3, and you can't put those together because they're not like terms. Okay, let's try a couple more. Let's say that we've got x squared plus 5 equals 8. X squared plus 5 equals 8. Is this in the right form? Something squared is equal to a number? No, it's not. It's not in the right form. It's not in a trinomial form, because remember we could move everything to one side and factor. That's not going to work either, but we could get it to something squared is equal to a number, because we've got something squared and we've got a bunch of numbers. So let's move the 5 to the other side and see if this looks like it's in the right form. Okay, x squared equals 3, that is in the right form. Something squared is equal to a number, and I know that I can take the square root with my plus or minus. It cancels on the left, and I get plus or minus the square root of 3. Okay, but it's very important that you get it in the right form before you take the square root. I don't want to do it in the first step. I'd end up with a mess. Okay, you've got to get it in the right form before you take the square root. All right, let's do one more kind of similar to that. Let's say we've got 3x squared is equal to 36. 3x squared is equal to 36. So it kind of looks like something squared is equal to a number, but that 3 out front makes it a little bit more difficult. We could take the square root on both sides. You could always take the square root on both sides, but you might end up with a mess. But I don't think that we want to just yet. We really want it to be something squared is equal to a number, and that 3 is not part of the something squared. Remember, exponents only go with what they're next to unless there are parentheses telling you otherwise. So let's go ahead and move the 3. Let's get rid of the 3 so we have just the x squared by itself. So it's 3 times x squared, so I'm going to do the opposite, which is divide by 3. So I get x squared is equal to 12. Now we're in the right form. Now I can take the square root on both sides. Don't forget your plus or minus. I get x is equal to plus or minus the square root of 12. And we're not quite done yet because remember, square root of 12 can simplify. So this is actually the same as 4 times 3. And we can take the square root of 4. That's going to be 2 square root of 3. So my final answer is plus or minus 2 square root of 3. Okay, so again, the key to this is that you want to get down to something squared is equal to a number. Now, let's look at some examples of when you cannot use the square root method. So this is when we're not going to use the square root method. All right, first of all, let's say we've got x squared plus x is equal to 6. X squared plus x is equal to 6. Is this in the form of something squared is equal to a number? It's not. If I try to take a square root here, I have to take a square root of the whole left-hand side and the whole right-hand side. You cannot do exponents or roots term by term. When I take the whole left-hand side, I end up with a mess because I can't break this up over addition or subtraction. The square and the square root don't cancel because they don't happen at the same time. And I've got this other x in here that's going to end up being a mess. So taking the square root here is just going to get me a bigger mess. Now you might think, well, I can move the x to the other side. Okay, let's try that. Okay, now I've got something squared. I take the square root. But we still have a mess here. I can't do anything with this. I've got square root of 6 minus x. I can't break up the square root. I can't get to x. Remember, we're trying to get to x is equal to a bunch of stuff that's not x. That's how you know it's solved. So I'm stuck here as well. So that really doesn't do me any good either. The key is that it's got to be something squared is equal to a number, just like we saw here. So in this case, I can't get it to something squared is equal to a number. I want to move everything to one side and then see if I can factor. So let's back this up to the original problem. This one is not square root method. This one is a trinomial. We want to try to get everything on one side and look to see if we can factor the reverse of FOIL. Yes, we can factor this. It's going to factor as 3 and 2. They multiply to be -6. They add to be +1. And we can break this up. X plus 3 equals 0. X minus 2 equals 0. And we're going to get -3 and +2. Okay, so this one is a trinomial. If we move everything to one side, it is not going, you cannot use the square root method on that. You got to be able to get it to something squared is equal to a number. Okay, so that's, so you're looking for basically 2 terms is what you can simplify it down to. All right, so you can't use the square root method on everything. When you can, it's great, but you can't use it on everything.